Welcome to this video. I'm going to present you the interactive visualization that has been developed in the context of the Ultimate European Research Project. This visualization is about greenhouse water reuse and fertilizer recovery. It's linked to a real-time Julia simulation model that runs in the background. So it's an online visualization that will run from a specific website. So far it's browser based. I run it locally for the purpose of this demonstration. So you can, in the normal visualization mode, pan and zoom to see every single component. All the different components are linked to each other. So the first component is a rainfall component. You can change the rainfall coefficient. So at the moment, by default, you start at 100% of the normal predicted rainfall, and then the simulation engine will project what will happen for the next 20 years. Once you have set up your rainfall, you then have access to the greenhouse interface, in which you can change the greenhouse surface area. You can allocate different types of crops inside the greenhouse and also change between drip and sprinkler irrigation. Note that when you start the visualization, you've got automatically only one type of crop selected, but you can divide your greenhouse into different types of crop and you allocate the surface in percentages. You can also change the irrigation technology performances, like the efficiency of drip irrigation, for example, as well as the rainwater storage capacity. The part that gives you the result is located here. So this big panel has what happens when, as an output, as computed by the model, once you change different parameters. So by default, when you start, you have 100% of your crops are tomatoes. So you can see the global information. If you use the system to have electrodialysis to reuse water and filter nutrients in order to reuse them, this is what you get. You save that amount of water per year, euro in euros. You save that amount of fertilizer, and you can see that the energy costs used for the treatment of the water actually exceed the savings so far. But we haven't added yet the penalties that you might have to pay if you discharge water which is not sufficiently treated. So this will probably change in the next few weeks. Note that the model is still in development, so is the interface. So this is a beta version. Things might change and be reviewed as we go. So to give you an idea of what's going on, I'm gonna, for example, change from a tomato-based crop to a cucumber crop, and then you're gonna see the consequences on the water use. So for example, if I plug and click on cucumbers, you're gonna see that the amount of water being used is lesser. Similarly, if you look at the nutrients in use, if I switch between cucumbers and tomato, it seems that the tomato crops use more nutrients. You can see the share of the different types of nutrients, and you also see, as you go down, things like the percentage reuse of nutrients used by the system. Note that we haven't activated yet the water quality monitoring variables, so it might either be sodium concentration or water conductivity. This remains to be determined. An interactive Sankey diagram also shows you how the flow of water gets in the system and what is being reused. Similarly, there is a Sankey diagram which is also constructed dynamically for nutrients. And finally, you get a table that shows you the quantity of nutrients being used and what is being saved for this particular crop. So everything is dynamic, so you can, for example, change your rainfall to have only, let's say, 30% of your initial rainfall, and then you notice that your freshwater requirement go up as expected. There is also an audio system in the background with an AI kind of voice, pre-recorded AI constructed message giving you information when you click on an information button. And we can at the moment change between a normal view and an isometric view where you have exactly the same kind of interaction, but you can make it look a little bit different. Note that the interface arranges itself and adapt to the size of the screen. So if you make your screen smaller, then it becomes a standard dashboard design that can adapt to a phone, for example, where the interface for changing parameters is available via a normal kind of phone accessible menu. As soon as your screen gets bigger, then you have access to the big dashboard again. So thank you for listening, and this is the present state of progress for the ultimate case study related to the Netherlands, the greenhouse case study. Thank you.